Good morning, guys. So we are going to start off today talking about transformations, okay? We're going to just look at transformations on the absolute value equations today. Eventually we'll look at other functions as well, but today we're just doing absolute value functions. In math, a transformation is how the function moves on the graph or how it's changed from the original graph or its parent function. So if you'll remember learning about parent functions in Algebra 1, your parent function is basically the simplest form of a family of functions, or functions that all have the same shape. Meaning, absolute value functions all have that V shape, right? This is the most basic, the simplest form of the absolute value equation, which is y equals the absolute value of x. Any V-shaped function that's not on the origin and not just like this, it's been transformed, okay? But it's part of the family of absolute value functions. So if we were to say we had a function that looked like this, it has that V shape, so you know it's in the absolute value family, but its little vertex down here is no longer at the origin, so it took the parent function and we transformed it. We shifted it up, we shifted it to the right, and then it also looked like it's been stretched higher vertically, right? It's more narrow than it was down here, okay? We're gonna get into all of that in a little bit, but even if it's been reflected down, right? This is still that V-shaped graph, so it's still in our absolute value family, but it's been transformed from the parent function, right? They took this basic equation and they added or subtracted different numbers, negatives, all kinds of things to make it transform into this, okay? All right, so here we have our parent function of the absolute value graph down here. We want to look at the table, okay? We want to kind of go through that. So I've given you some x values. These are our input values. I want to input each of these x values into the equation and see what it gives me as my y value. Its corresponding output, or the y value, right? So we'll label it. This is going to be our input. X is always your input. Y is always your output. Maybe y'all remember that from Algebra 1. Maybe not. All right, so if I took this equation, y equals the absolute value of x, and I looked at it when my x is equal to -2. We'll write it on here. We'll say when x equals -2, we're going to plug into our equation up above, but instead of putting an x, I'm replacing x right here. I'm replacing the x with what x is equal to, which is -2. Okay? So we're going to see, what is the absolute value of a -2? Well, the distance -2 is from 0 is 2. So the absolute value of a -2 is a +2. Okay? So that means that when my x is -2, my y value is 2. So we would have this as a coordinate point if we wanted to plot it on our graph. So I'll go ahead and fill in my table up here. When I put in -2 for x, the output value is 2. Let's look at our graph. If I went to -2 on my x and then up to +2 on my y, I have a point right here on my function, right? So then let's try it when x equals -1. We're plugging in, now for where x is, we're plugging in what x is equal to now because we've moved down to an x is -1. So we're putting in -1 in our absolute value signs. So the absolute value of -1 is a +1. So then I can put this in my table. When x is -1, my y value is 1. And if I wanted to look at that as a coordinate point, when my x is -1, my y is 1. And if we looked at that on our graph, negative 1 on my x-axis and positive 1 on my y-axis would put me at that point right there. And we could keep going. Okay, we would put in a 0 where x is. If I put a 0 here, the absolute value of 0 is 0. Okay, if I kept going and I put in the next number, a 1 here, the absolute value of positive 1 is still a positive 1. The absolute value of positive 2 is positive 2. That would be our table, right? So graph our point at 0, 0, graph 1, 1, graph 2, 2. All right, so another refresher from Algebra 1. If you see this, f parentheses, x parentheses, it is pronounced as f of x, okay? This is how I'm gonna be saying it. So when I say f of x, this is f of x, okay? Meaning basically you have some function, right? A function's basically an equation where your y values don't repeat, okay? Hopefully you remember this from Algebra 1. But we have some function where x is our input value. That's basically what this is telling us. F of x is the same thing as y, okay? They use f of x just to say this is a function of x. X is our input, okay? So f of x and y are the exact same thing. You could see equations written like this or like this. They are the same thing. It doesn't matter whether they put a y equals or an f of x equals. F of x and y are the same, okay? F of x is equal to y. They mean the exact same thing. It doesn't even always have to be f of x. That's just the most common one. Other times you'll see it written as g of x or h of x. It's just naming that function, function f or function g, function h. They're always of x, okay? So if we were looking at this table we made a second ago, I put y for this table, but I just as easily could have put f of x. A lot of the times you'll see tables where it says x and f of x, but f of x is just your y value. They're interchangeable. So for today's lesson, we're just hitting on the very basics, just introducing it, okay? So first example says fill in the missing values in the table below if f of x equals the absolute value of x plus 6. And I've already given us some input values just to practice with, okay? So you're basically doing what I just did a second ago. If this is my equation, you can see it's no longer just our parent function, right? We've added this 6 on the end. That means our parent function has been transformed. It's been shifted in some direction. All right, so let's hope this works. So Desmos.com is one of the best graphing websites. Y'all are more than welcome to use this website. So here we have graphed our parent function, okay? See how the vertex is at the origin. Your origin is the point 0, 0. It goes through point negative 1, 1, negative 2, 2. Over here it goes through 1, 1, 2, 2. This is our parent function, okay? You see I have it graphed as y equals the absolute value of x. And now we're going to graph that function I just showed you. So we'll do y equals, to find the absolute value bar, you're going to go down here to the bottom left. And you'll see it right here with the letter A in the middle. That's your absolute value. So inside of my absolute value bars, I'm just putting an X. And then I'm going to do my arrow over and go outside of the absolute value bar. And I'm putting the plus 6. Okay. And I'm going to hit enter. So it'd been better if I had been zoomed out from the beginning. But what happened? So you can see our red graph is our parent function, and the blue graph is absolute value of x plus 6. It's the one that we transformed. Notice what happened here. From our parent function, the red one, it went up to, it went up to 6. So So nothing else changed. It's still equal distance apart right here, right? All that happened is we took this original parent function and we just moved it up 6, okay? So it's been transformed. It's no longer the parent function. It's now been moved up 6. That's all that is, okay? So we could say that the blue function is now higher than the red function. The blue function's been moved up, right? Okay, so if we're looking at our table, say we didn't graph it. We wanted to try graph it ourselves. We didn't just graph it on Desmos. We could graph it ourselves using our table. So when my x is -2, when x equals a -2, I'm going to plug in. So we'll have y equals f x and y are the same thing, right? Say y equals the absolute value of, instead of x, I'm putting -2 plus 6. I cannot just combine -2 and 6 because -2 is in absolute values. So what I need to do is first simplify the absolute value of -2, which is a +2. And +2 plus 6 gives me 8. So when x is -2, my y is 8. Okay, and we can keep going. So when x equals a -1, then we're going to have y equals the absolute value of -1 plus 6. We know the absolute value of a -1 is +1, and 1 plus 6 gives us that y is 7. Okay, when x equals 0, we're now plugging in 0 for x. Absolute value of 0 is just 0. So 0 plus 6 is just 6. And I'm running out of room. So we'll say x equals 1. We have y equals the absolute value of 1 plus 6, which gives us 7. And when x equals 2, we have y equals the absolute value of 2 plus 6. Well, the absolute value of 2 is just 2, and 2 plus 6 gives us 8. And there we go. All right, so here's our table. Here's our graph we were just looking at. So at -2, if I go up to my y-axis, we're at 8. At -1, if I go up on my y to the blue function, we meet the blue function at 7. 0 max, we're at 6 on the y. 1, we're also at 7, and 2, we're also at 8. Sorry if you couldn't see that. 1, we're at 7, 2, we're at 8. Okay? Okay, for our next example, our next function we have is g of x equals 5 times the absolute value of x. This is different than the equation we had before. The equation we had before, the number added was off to the right, and it was plus 6, right? Here, there's nothing between 5 and my absolute value sign, which means they're being multiplied, okay? So this is going to be a different transformation than what we had before. So let's look at it. All right, so now let's look at how this would transform our graph, okay? Our newest equation. So I'm going to do y equals 5 times the absolute value of x. So all we did is we just multiplied our absolute value by a 5, right? That's all that's different from the red to the purple, okay? My graph didn't shift up or down, left or right? The origin is still, or our vertex is still at the origin, right? But what happened? Our V shape got a lot taller, a lot higher, right? A lot more narrow. So it's more narrow vertically, right? It's gotten taller vertically. It's not quite as flat as the red one, right? So what we call this is a vertical stretch, okay? Because you took the red graph and it's basically like you took those sides and then you stretched them upwards. You pulled it upwards, right? So we call this a vertical stretch, This is what happens when you multiply your absolute values by a number greater than 1. So 5 is greater than 1, so we end up with this vertical stretch.